Hi everyone, back here to give you a review on factoring by grouping. So you are seeing right now that I'm going to review with some of your guys' submissions. So that's why I had you guys submit them so I could see what mistakes you might be making and try to fix those. So I'm going to use those without any names attached. If you feel like you have this idea of factoring by grouping down, I would suggest try pausing the video at each problem and with a blank sheet of paper try to see if you can figure out if there's a mistake, what it is, how you fix it, if it's correct, whatever you think it is. And then scan ahead and see if you're right. If you feel like you're still struggling, just listen through this video. Hopefully it will help. Okay, so we're going to be kind of jumping around on the problems, but I took different examples and this is what they're going to kind of look like. So this very first one, 105n cubed plus 175n squared minus 75n minus 125. So interesting thing that happens here is that every term, even though there's 4 terms, and usually that means grouping, every term has a 5 in common. So the first thing you want to do in this problem is the GCF. So this is also a reminder of what you're looking for. You always look for the GCF first. So this first step here between here and here is a GCF, and this is done very nicely. Every one of them are divisible by 5, and then you have your leftovers in parentheses. The next thing that happens here is you factor what's in the parentheses by grouping. Okay, so you're using that grouping method to factor here. Okay, so the first 2 sets of terms right here had a 7n squared in common. Okay, so you divide that out and you have a 3n plus 5 left over when you divide that out. The last 2 terms here had a negative 5 in common. Now this is going to be something that comes up multiple times here. If this first term is negative, you're going to take a negative out with your GCF. Okay, and that's also going to change the sign of your second term. So when you do negative 15n divided by negative 5, you get 3n. When you do negative 25 divided by negative 5, you get positive 5. Okay, you do notice that your 2 terms are equal to each other, and so therefore that can be written as one of your terms, and then what you had as your GCFs is written as your other term. It does not matter the order that these are in, and then make sure you carry your GCF with you. So this one is a correct answer. We look at the same problem down here, done differently, so they did not notice that there was a GCF. Now here's the good thing. You don't have to find the GCF first. It just usually works in your favor, okay? So this step here is actually done perfectly fine. There's nothing wrong with that step. They found what these 2 factors had in common, what these 2 terms had in common, factored them out, had something in common. We did that in our leftovers. The only problem with this is that this factors more, okay? So you need to realize that, hey, that factors more and go ahead and do it. And this happens to factor. You can divide both of those terms by 5, and then you'll end up with a 7n squared minus 5 left over, which gives you the same 3 factored terms that you see in this first one. Okay, so your answer here is that right there. Moving on, we had, I don't remember what question number this was, but we have 2 of them here that were submitted. This very first one is correct. The second one, we've got a lot of questions. I'm going to go over the questions first, and then I'm going to come back to how you do this one. Very good job in recognizing that you can make this step. However, if we are factoring by grouping, you don't want to do this. Okay, to factor by grouping, you're going to use 4 terms, and we're actually going to find out later on how we take a 3-term polynomial and make it into a 4-term polynomial to factor by grouping. So that's why you're seeing some of these right now where they have the same or like terms in the middle, and you could combine them, but it's easier to factor by grouping than it is to look at what we have here. Okay, so we will be learning that in the future, but for right now, we don't want to do that. So if you look at the rest of this, it's kind of obsolete. You cannot just take the 6 and put it in front here unless it's a GCF. So since you can't divide the x and the negative 15 by 6, you can't just put it out front like this. Okay, it would have to come into this. And this is one where you would say that the 6x squared, it has to be this first term and first term have to multiply to that, and you'd figure out what goes there. To do it in this format, we're going to look at the examples where a is greater than 1. And again, that's what we're leading into at the end of this week. So if you look over here, you just take this and you have your 2 groups. So 6x squared minus 9x has a 3x in common. Your leftovers are the 2x and the negative 3. Your 10x minus 15, positive number, so a positive number comes here, is a positive 5 with a 2x minus 3. One other thing to note is put this positive here. It's either positive 5 or negative 5, plus 5, minus 5. It's one of those things. Do not just leave it as 5, okay? And then factored completely here. Again, to remember how we're doing this, these two are essentially our greatest common factor in this case. You factor those out, and what's left over is the 3x plus 5, and that goes as your other factor. So this is your correct answer right here. Again, something else we're going to get into here, and we can talk about that, but definitely don't do what is done in here. Okay, good questions though. Okay, number 17 was 24b to the third plus 32b squared minus 3b minus 4. And overall, this is really done well. Okay, you find the greatest common factor of these two terms here, which is 8b squared. I like that this person has written the division sign. And then negative 3b minus 4, as soon as this first one is negative, you divide by a negative. So we've got negative 1 in this case, also a really good thing to recognize that we have a 1 that we can divide by. Okay, you have your greatest common factor up front, your leftovers, your greatest common factor, your leftovers. When you divide negative 3b by negative 1, you get a positive 3b. Negative 4 by negative 1, you get a positive 4. The only thing I don't like is the way that this answer is written, okay? I'm not sure if this is meant to be an equal sign or what, but you definitely don't want that here. When you see this and you factor it out, one of your factors is 3b plus 4, and your other factor is 8b squared minus 1, okay? If anything, this is a multiplication sign in here, but otherwise you don't want anything there, okay? But other than that, I liked the answer here, so we have the right idea there. Number 26, 4jk minus 8j squared plus 5k minus 10j. So we've got two different variables involved. Looking at these, look for numbers and variables. So 4 and 8 are both divisible by 4. You have the j and the j squared, so the lowest exponent is going to be your greatest common factor, so just 1j. And then a k and no k's means the k is not in the greatest common factor. So that's where the 4j comes from. 4j is out front. Divide 4jk by 4j. So 4 divided by 4 is 1. J divided by j cancels. K is the only thing that's left. 8 divided by 4 is 2. J squared divided by j leaves 1j left. And there's that minus sign still in there. Okay. You can look at this one then and notice they're both divisible by 5. They don't have any variables in common. So 5, you have a k minus 2j left. You do have the same thing in those parentheses. You can write that as one of your terms and your two greatest common factors. Okay, so this one was well done there. Number 13, so this is a very, very common thing that comes up here. 9x squared minus 9x, we did this one perfect. We have a 9x and then we have an x minus 1 here when you divide it out, okay? What you want to do, and I mentioned it earlier, is there is always a plus, a minus, whatever sign here, because you want this to be equal to what you had here. And right now, technically, this is saying multiply. We don't want that to do, we don't want to do that, so then we need to add a symbol. Okay, now in this one, you should start to notice that, okay, something happened, something was wrong, whatever. They've got, you can see them writing in this negative x plus 1 in here. Well, what we want to do is as soon as this last set of terms has a negative first, you want to take a negative out with it. Okay, so this is a negative 1 as the GCF. If I divide this by negative 1, I get a positive x. And if I divide 1 by negative 1, I get a negative 1. So I have a positive x minus 1, which actually does match this first thing. And so then we can say that it's the x minus 1 is one of the terms, okay? And then the two GCFs are the other one, so it's 9x minus 1. And so that's where you get your answer from. Again, very, very common mistake, but pay attention to those negative positives, and I really like that you noticed the 1. Number 15, this one was done well, so it was submitted to me. Again, I know some of you submitted me ones that you knew you had, but I asked for a submission. So these first two terms have a 2x squared in common. If you divide by 2x squared, you get 6x minus 7. These last two terms. So notice this person did it in actually two different steps. That's why I grabbed this one. So they did that first step there and they've got that. And then they're concentrating on the second step. So first step, they did the first grouping, just wrote everything else. Second step, they did the second grouping. You've got that. You can now see that your two parentheses are exactly the same. You write those together and then you write your 2x squared plus 7 last. So this one was done well. It was just a different way to do it. Maybe that helps some of you. So I like to show those. 23, we have 4xy plus 32x plus 20y plus 160. And it looks like we're looking at 32 and saying, okay, that's 4 and 8. 4 times 8, 20 is 5 times 4. So just to get some ideas down here. But a few things went wrong here. So if I look at these first two terms, I want to say, what do they have in common? So yes, 4, 32, I can divide by 4. So 4 is part of the GCF. But we also should recognize that there's an x in both of those terms. So it should be 4x out front there. Okay, when you divide this by 4x, you do get y. When you divide 32x by 4x, you do get 8. So this is all correct here. Now I want to look at this next set of terms here. and see what they have in common. And what I should dividing both of them by is by 20, and it's a positive 20. So should have a positive 20 in here. And then I should look for what's left over. Well, if I divide 20y by a positive 20, I'm going to have a y left over. Okay, divide a positive 160 by a positive 20, and you're going to have an 8 left over. So that's how you're going to fix this one, okay? And if you ever have the two parentheses don't come out the same like you did here, you know something went wrong, okay? So stop there, don't make more stuff go wrong. But if we do that, then we get this 4x plus 20. So those are our GCFs written together, and we get that y plus 8. Only write what's in the parentheses once because you're essentially factoring that out, and you have this. Now, this is not a complete answer because technically way back here, you had a GCF you could look at. We've already talked about the idea that if you skip the GCF, you don't have to go back to the beginning to do it. What I do is I look in here, y plus 8 does not have a GCF, but 4x plus 20 does. I can divide both of those by 4. Okay, so I treat the problem as if this was the only problem. Divide it by 4, I put that out front. In parentheses, I put the leftovers. So 4x divided by 4 is x. 20 divided by 4 is 5. There's a plus sign in there. Okay, and then I didn't do anything with this, so I just leave it alone as another factor. So your final answer for that one is right there. Struggle here, so 4xy plus 6 minus x minus 24y. So this one actually forces you to reorganize your work, okay? And this person did this perfect. So we want to reorganize here, especially when you have different variables. You know essentially the y's have to be either the first and the third one or the second and the fourth one. The x's, have to be somewhere in there too. But this person did a really good job of organizing the variables here, and this one worked out fine. So this step is perfect, okay? This is just an organization step. And then we need to go from there. Okay, so we look at 4xy minus x. Okay, they don't have any numbers in common, but they do have an x in common. So we're going to have an x out front, and then the leftovers in that case, divide this by x, is going to be a 4y minus, divide this by x, you're going to have a 1 left over. Okay, look at the second set, negative 24y plus 6. So as soon as I see this negative, I'm going to take a negative out. Okay, 24y and 6 can both be divided by 6. So it's a negative 6 I'm dividing by. So negative 24y divided by negative 6 leaves me with a positive 4y. Okay, 6 divided by negative 6 leaves me with a negative 1. Okay, and then this is where you're getting to this final answer. So this final answer is correct. I'm not sure that the steps in between actually lead to that final answer. So you really want this as kind of your step in between. Okay. Very common difficulty here. We've talked about it a little bit, but in number 12, we've got our setup. Okay. The rest of this is fine. When you see that what's in parentheses is exactly what you have in your second set, that doesn't mean that you skip factoring by grouping. Okay. That means there is no GCF here other than 1. Every single thing has a GCF of 1. There should be a positive 1 in there. And then that gives us this x minus 7 and this 5x plus 1. I will see a lot of common mistakes here that tell me then that it's x minus 7 and then it's 5x if you don't put that plus 1 in there, okay? The plus sign has to be there. Put the plus 1 in there so that you don't make this mistake. So don't do this. Okay, what this student did was just fine. Just make sure you're very careful with that plus 1 in the middle. Okay, you want every line to be equal. Okay, 23, I had a question on this one, and the interesting answer to this is do not factor by grouping here. Okay, you only have 3 terms. So factoring by grouping, you're going to do when you get 4 terms. Okay, now I did allude to this earlier. In this one, you could possibly lead to factoring by grouping, but this is one of those where you're going to do a trinomial with an a value greater than 1 and working through that. And later on, we will learn a method where you change this to grouping in order to solve it. But just do not factor by grouping here. Okay, do not do this. Okay. Moving on here, we had one that was done perfectly well, but again, an example with different variables. So just looking through it real quick, we have our first 2 terms here that both have a 3x squared in common, so that's what they took out. The leftovers, so when you divide 12 by 3, you get 4, x squared by x squared, it goes away, and then the u's left over, plus sign stays. 3 divided by 3 is 1, x squared divided by x squared goes away, and there's a v left over. That's what they've got there. You look at the second set, 28 and 7 both have a 7 in common. There's the y in both of them, so 7y. 28 divided by 7 is 4. Y divided by y goes away, and u is left. 7 divided by 7 is 1. Y divided by y goes away, and the v is left. Okay, and you see that your parentheses are the same. You write those down, and then you write your GCFs as your other term. Again, notice every single time we've written these are multiplication in the middle there. So you do not have to write the symbol in. Okay. Another one happening here, and just interesting to see how it worked. Okay, so the step from here to here, perfectly fine, all okay. Okay, then we go from here to here, and some of you will catch this, some of you won't. But if you look from here to here, you're like, okay, there's the b plus 4, I see it. But then where the heck did 5a plus 3 come from? Okay, well, where it came from was technically this step is taking us to a b plus 4 and then a 10a plus 6. And then this is where you have to recognize that there is a GCF in 10a plus 6, and they did. It's 2. So you take a 2 out and then divide. 10a divided by 2 is 5a, and a positive 6 divided by 2 is a positive 3. And then we still have this other term that I didn't do anything with. It's common practice to, if you have a monomial, put it first. So I'm just going to put that b plus 4 at the end. But you do get this as an answer, okay? It's just not quite clear going from step to step there. Okay, and then the last one is the one that I had the most questions about, the most pictures of, okay? So I have some good over here on the right and some problems that came up over here on the left. Let's go through how to actually do this, okay? And I'm gonna use this bottom right example here. So 24AB and 64A, okay, both have 8A in common, so divide both of them by 8A. 24 divided by 8 is 3. A divided by A goes away. The B's left over. 64 divided by 8 is 8. The A divided by A goes away. Okay, I really like how this one is organized. So you can see that first part. Divide both of these last two terms by -7. You end up with the 3b plus 8 left over. And then you can see how they underlined. Their GCFs are double underlined. So that's your second grouping. And your parentheses are single underlined. So that's your first grouping that's here. So this is our correct answer that we're leading. Okay, this one's done almost the exact same. The one thing I want to point out is notice that their answers that are both correct are written differently because the factors can be in whatever order. 2 times 3 is 3 times 2. It's the same idea here, but with binomials. So this first example, first of all, they had a 54 here, but I think they've figured out that problem, so I just fixed that. But the first problem here is if you divide by -7, negative 21b divided by -7 is a positive 3b, but negative 56 divided by -7 is a positive 8. So that's going to make both of these the same. Now, I do like that this person didn't continue on when those were not equal to each other because something went wrong, but that's what you can check. So then your answer, you can take your 3b plus 8 and your 8a minus 7 as your two factors. Okay. Here we have very similar problems happening here. The first thing in this one that you should notice is 6b plus 16 can still be divided by 2, which means that this needs to change to a higher GCF. It is important that you find the GCF in these ones. Okay. And then I also noticed that negative problem that was happening here. So when you do -7, this should be a positive 8. And what you should notice between these two parentheses is that they're only one of them's double the other. And that means that this one should be able to divide by that too. Okay, and then lastly down here, we look at it and we've got some factor treeing going on. So I thought this was an interesting approach. If you need to do that, go right ahead. Figured out that both of them are divisible by 8, but this person didn't take into account the a's that are also divisible. So you have to put an 8a out here, and that makes this 3b plus 8. And they did this last one correct, -7, 3b plus 8, and then that allows you to lead to your final. Okay, hopefully this video helped. Let me know if you have any more questions about this.